Welcome to the Great Indian Developer Summit. I hope it's been a good morning so far. Keynote was good. Yeah. Dino Esposito and I are old friends. He did a fantastic job this morning. So it's the beginning of the week, and we want to make this as fun and productive a week as it can possibly be. Obviously, we have a lot of content to present this week and to help you learn, to make you a better developer. And before I start talking about HTML5, I wanted to share with you a URL. It's the URL that's on the screen here. It's a URL to a zip file that I've put on my SkyDrive. Make that OneDrive. It's still hard to remember not to call it SkyDrive, isn't it? I'm going to show you a lot of code samples in this session. And if you would like a copy of those code samples for yourself, go to this URL at your convenience. And you can download a zip file. It has tons and tons of HTML5 code samples in it. You're welcome to do whatever you want with those samples. You can share them with friends, share them with colleagues. I write these to teach so that people can learn about the cool things, not only in HTML5, but in Microsoft platforms. And I'm happy for you to share those. Remember, since this is a OneDrive URL, it is case sensitive. So those last few letters and digits there, make sure you get those right. I'll put this up again at the end of the session in case you did not have a chance to write it down. So again, you can go to this URL at your convenience and you can download a bunch of HTML5 code samples, some of which I'm going to show you in this presentation. So I decided to title this presentation HTML5, the good, the bad, and everything in between. And here's why I decided to do that. HTML5 is a big deal these days, isn't it? Even if you're a developer who has worked on the Microsoft stack for years and you've done nothing but C# and .NET, it's hard not to be touched by HTML5 today. Everybody's talking about it, and for good reason. Because with HTML5, what we essentially have is an operating system in a browser. We have standard APIs that browsers expose. It is absolutely true that HTML5 allows us to do more with JavaScript applications and browser-based applications than we've ever been able to do before. But it's kind of interesting, too, especially if you're a .NET developer like I am. When you look at HTML5 and you compare it to what people have told you, oh, in HTML5 you can do anything you can do in WPF or in WinRT or in Silverlight, what you find is that's not true. There are a lot of positives about HTML5, but there are negatives as well. Let me tell you something. I love HTML5, but my passion is writing native apps. Whether those are native apps for Windows 8, for Windows Phone, sometimes even Android and iOS. I can always build a better app if I make it a native app. But you know what's great about HTML5, especially in the mobile space? Back home in the US, when customers call us today, call Wintellect, asking us to do app dev for them, very often they want that app dev to include mobile devices. And the last thing they want to do is pay us to write that for all the different mobile platforms. They don't want one iOS version, one Android version, one Windows Phone version, one BlackBerry version, whatever. They want one version that will run on all those devices. And that's where HTML5 comes in really, really handy. So what I would like to do, especially for you .NET developers out there, is show you what I think are some of the most compelling, important, and prolific features of HTML5. And yes, we will talk about what's good about these features and what's not so good, what maybe wasn't done all that well. Now, with each of these features I present, and we're going to do mostly code in this session, by the way, but with each feature that I present, I'm going to show you, as you see here, a list of pros and cons. The first feature I want to show you is the Canvas API in HTML5. Now, it's interesting. HTML5 has dozens and dozens of feature sets in it. Some of you may know, or maybe you don't know, there is no one specification you can go download anywhere that describes all the features of HTML5. Rather, it is described in a set of specifications. So you have to go read that family of specifications to learn about all the features. There's not even complete agreement on what HTML5 is. There are some features of HTML5 that technically are not part of it. WebGL is one of those. A lot of us consider it part of HTML5, but technically it is not. So the Canvas API is one of those features that almost all developers know about. If you've heard about HTML5, you've heard about the Canvas API. What does it allow you to do? It allows you to write JavaScript code that draws directly into a browser window. Now, if you're a C# developer, that's no big deal. You've been probably writing code for years and years and years. Maybe in the old days it was using GDI to draw into a window. But over in the web world, the JavaScript world, it is quite significant that we finally have the ability to draw into a browser window. If you look at what customers in the U.S. are doing with this, they're finding all sorts of uses for it, everything from games and animations to line of business applications where we make a call out to a REST service on the web somewhere. We pull back a bunch of data, probably JSON data, and then we generate on the client side right there in that browser using the Canvas API, we generate charts, graphs, and things like that. If you've never seen this API before, I want to show you what it looks like and show you some examples. Because you can do some very, very cool things with it. If I were grading the Canvas API, I would probably give it a B+, maybe even an A-, because you know what? It is a good API. It's a good API to have. Now, I'll tell you this. Here's what I don't like about it, and what you may not like about it if you have experience writing graphics code. This is a primitive API. 20 years ago, it would have been big news. It is a very, very rudimentary API. It's not like XAML and SVG, a retained mode graphics subsystem. It's a primitive 2D API. If you want to draw a line in that browser window onto a canvas, you may do that. Now, it does have some advanced features, but it is not nearly as advanced as many of the graphics APIs and languages that are available today. Nonetheless, it is an important part of HTML5. Now, for those of you that have never seen Canvas API before, let me show you an example or two here and show you some cool stuff you can do with it that even if you have used this API, you may not have thought of. What I'm going to do is go into Visual Studio, and I'm going to bring up the solution that's in the zip file whose URL I showed you at the very beginning. It'll be in my samples folder. Let's go over here. The solution is called HTML5 Demos, and there are lots and lots of sample pages in here demonstrating various features of HTML5. There's one example right here that I'll run first. So this one uses the Canvas API, and what it does is quite simple. When this app starts up, when this page starts up, it programmatically loads an image, the image that you see in the browser window. Then it uses the Canvas API to cut that image up into pieces. In fact, each of these pieces, a piece of the puzzle, is independently movable. Just like a child's puzzle game, I can click one of these things and move it to the empty square. Each of those 11 puzzle pieces measures exactly 150 by 150 pixels. Each is an HTML5 canvas. What I'm doing there, again, when this page loads up, I load the larger image, programmatically cut it up by drawing different pieces of that image onto different canvases. Then I use a little bit of jQuery to wire up event handlers so that I know when one of those pieces is clicked, and I use jQuery's animation engine to make the piece slide. So we're actually seeing a little jQuery at work here too, but this app would not be possible if it weren't for the Canvas API. Let me show you really quickly what this looks like. If you look at the DOM first, you'll see those 11 canvases that I've declared, each one measuring, again, 150 pixels square. I've used absolute positioning and CSS to align them in rows and columns. Each is an HTML5 canvas, as you can see here. Then, if you look up at the top, you'll see the startup code for the page. And right here is a jQuery ready function, wanting to make sure that this code executes at exactly the right time in the page's lifetime. Check. Did I hear the mic go out? I do a quick check to make sure that this browser supports the Canvas API, because this page can't work without it. And then, if I've determined that it does, I load that image that you saw, wait for that image is loaded, and then in this nested for loop right here, this is where I'm using the Canvas API to cut the image up into little pieces and draw them onto the individual canvases. The key call is this called the draw image, which is one of the methods in the Canvas API. After that, it's just ordinary browser stuff. Here I'm asking jQuery to find all the canvases in the document. I'm using jQuery to wire a click handler to each, and this is the code that when one of those canvases is clicked, checks to see if the one that was clicked is adjacent to the empty square, and if the answer is yes, moves it left, right, up, or down using jQuery's animate method. So that's one use for the Canvas API, taking those images that you've loaded and cutting them up. But let me show you something else you may find interesting here. And by the way, I am moving fast intentionally because normally when I speak at a conference, usually the sessions are an hour and a half. We have 1 hour, and I want to fit in as much as I possibly can. So forgive me for moving quickly. If I'm moving too quickly, if I'm talking too fast, let me know, okay? I'll slow down a bit. But we're going to try to fit in just as much good stuff as we can here. So let's go over here to Solution Explorer. And I want to show you another one of these examples from my Canvas folder. This one is called, actually this one is in the files folder. It's called photofinish.html. And here's what it looks like. This one actually uses two HTML5 APIs. One, the Canvas API, and two, the File Reader API. This is an input type equals file element at the top. When I click it, the browser will pop up an open file dialog. I'm going to go over to my pictures folder, and I'm going to select a picture of my daughter. Now, this picture is old. She is 20 years old now. But I brought this picture with me. By the way, she got engaged this past weekend. So for the next 13 months, she and my wife are planning the wedding. I've already been told that a father's job in planning the wedding is to keep your opinion to yourself and have your wallet always open and ready. And that's exactly what I'm trying to do. Now, it is an old picture, but the reason I chose it is, can you see those red eyes in the picture? When I took this picture years ago, the eyes were terrible. Watch this. Did you know you could build Photoshop in a browser today thanks to the Canvas API? I'm going to click those red eyes, and I'm going to fix them. So I need to click that one again. And I'm going to fix it. Let me tell you briefly what's going on here. One of the cool things about the Canvas API, and it's a little-known part of the API, is that you can generate images from scratch with it, or you can take existing images and you can get read-write access to their pixels. Now, you think about that. In this case, when this canvas on which I've painted this image is clicked, I run a simple red-eye reduction algorithm on the pixels in the area of the click. It's a simple algorithm, but very effective, as you can see right there. Now, with that, I could build something much more sophisticated. Again, if I wanted to build Photoshop in a browser, since you have read-write access to all the pixels with the Canvas API, you could go much, much further than this if you wanted. Let me show you really quickly here where the Canvas API is being used in this page. I'll try to be very judicious with this, but I want you to see it. So this page, again, is named photofinish.html. When you look inside it and you look at the DOM, you'll see there's not much there other than an input type equals file element and a canvas. What I do is this. When the user chooses a file, I use HTML5's File Reader API, which I'll say more about in a few moments, to open the file. At this point, I'm actually checking to make sure that it is an image file that's been loaded. More importantly, once I've loaded the file, and I've decoded the bits and drawn the image onto the canvas, then I use this click handler right here to let me know when a red eye has been clicked. And what I'm doing here is first figuring out where in the canvas the click occurred, because, again, I'm only running this red eye reduction algorithm in pixels in the neighborhood of the cursor. And then ultimately, I pass those coordinates to a helper function named fixRedEye. Now, if you're interested in knowing how to do read-write access on images, take a look at this function right here, because in this nested for loop, I'm looping through the pixels under the click point and in the vicinity around it. The key is this property right here, the data property of the image data object in Canvas API. You like that property, huh? The entire bitmap is exposed, exactly right. So here's the deal. In HTML5 land, what most of us would refer to as a bitmap, they're called image data objects. So think of an image data object as the HTML5 equivalent of a bitmap. Every image data object has a property named data, which is essentially a byte array. There will be 4 times as many elements in that array as there are pixels in the image. So each byte gives you access to one component of each pixel, the A, R, G, or B component of that pixel. Like you said, everything is laid out. You can read and write every value. Now, let me show you something else. You don't have to start with an image like this. You can just generate one from scratch if you want. Take a look at this page in my Canvas folder named Mandelbrot.html. Now, I'll bet almost everyone in this room knows what Mandelbrot is, right? It is the most famous fractal in the world. I've always been fascinated by fractals. Take a look at the UI in this page. It is nothing but an image, and I'm not loading an image. What I'm doing is when this page starts up, I'm programmatically generating each and every pixel for this image to show a zoomed-out view of the Mandelbrot set. But then take a look at this. What I can do is I can click and I can zoom in. Now, this is a CPU-intensive app. There are about 1 million pixels in this image. To compute the color of each pixel, I sit in a big for loop, and I have to go through that for loop for each pixel up to 128 times. You can see it actually takes a few seconds to generate the image. In fact, depending on the complexity and the depth, it can easily take 15 or 20 seconds, and this is on a quad-core CPU. So there's the Canvas API. It's very cool. I'm just creating an empty image data object. And I am looping through this time computing pixels. But the performance is not very good, is it? For those of you that work for consulting firms, would your customers be happy with performance like this? You click and 20 seconds later something shows up? Yeah, no, they would not be happy with that. Well, that's life with JavaScript, right? I mean, isn't this the nature of working with JavaScript? It's an interpreted language. Most of us are C# developers or C++ developers. Things are just going to be slower in JavaScript, right? Well, maybe not. So I have worked as a contractor for Microsoft for over 20 years. Only one time has someone at Microsoft tried to get me fired. Do you want to see the demo that almost got me fired? No, you don't want to see that. Okay, you want to see the demo that almost got me fired. Here's the demo that almost got me fired. Here we go. Let's take this URL here, and instead of running it in IE, I'm going to run it in Chrome. Yeah. I'll bet a lot of you didn't even know this browser called Chrome existed, huh? Well, take a look at this. As fast as I can click. Yeah. Now you see why they tried to fire me, right? Let me tell you a little bit about something here, folks. For you C# developers or C++ developers like me, JavaScript is not what it was 10 to 15 years ago. Did you know all modern browsers JIT compile JavaScript? It is JITted the same way C# is JITted, the same way Java is JITted. In fact, it's not uncommon today to find JavaScript running faster than C# code. Both Chrome and IE do have very sophisticated JavaScript jitters. But remember, JavaScript is a typeless language, right? Everything's a var. You don't know what it is. You just know it's a var. That means when you are a compiler writer and you're writing a JavaScript jitter, you have to make some assumptions. It turns out that the team at Google that writes the Chrome V8 engine optimized their JavaScript jitter for floating point math. Well, guess what? The Mandelbrot computations, heavily floating point. Over in IE land, in Redmond, Washington, they tend to optimize their jitter more for integer math. So the bottom line is I could build a demo that makes IE look 10 times faster than Chrome. But because this demo here is so heavy on floating point math, it actually makes Chrome look really good. But here's why I wanted you to see this. The nice thing about HTML5, not just the Canvas API, but all the APIs, is that you have standard APIs that are supported in all the different browsers like IE and Chrome and Firefox and Safari and others. But do not make any assumptions about performance. You may find that the exact same code executes vastly differently in different browsers. So you have to test, and test some more so that you don't get bit by pushing something like this out to a customer, only having testing in a Chrome, only to have your customer come back and say, hey, what's the deal with IE here? So I won't go through the code, but again, you can download these samples and check it out for yourself. Again, it's using the Canvas API, this time to generate an image from scratch. Not only when the page starts up, but each time it's clicked as well. Now, let's do this. Let's go back to PowerPoint for just a moment. Because I want to talk about web workers. Out of curiosity, how many of you have heard of this feature of HTML5 before? Web workers. Okay, good. Not that many people, comparatively speaking. This may be the most important feature of HTML5, and there are a lot of folks who have worked with HTML5 extensively that don't even know that this feature exists. You know what web workers are all about? Multi-threaded JavaScript. Did you ever think you would see the day, especially you C# developers out there, when developers could write multi-threaded JavaScript? We can do it today. In fact, web worker is a euphemism in HTML5 for what most of us would think of as threads. Now, number one, why do we care about multi-threading in JavaScript? Is it a good thing? It is. There are two reasons we care about multi-threading. And the same two reasons are equally applicable to JavaScript and C#. When you write multi-threaded code, you typically do it because you want the app to be not more performant, right, but more responsive. You're trying to get away from doing long-running calculation loops on the UI thread, because in a Windows application, when that UI thread isn't pumping messages generated by user input, that app is dead in the water to user input. So in Windows, we fire up threads, or we borrow threads from a CLR or process thread pool, and we delegate background work, long-running computational work to those threads. You know what? We have the same need in JavaScript. Last thing you want to do in JavaScript is start a very long-running loop on the UI thread, because in most browsers, that browser is going to be dead to user input until you're finished. So why do we care about multi-threading in JavaScript? Because it allows us to build more responsive applications. There's another reason as well. Almost every one of us today are computing on multi-core devices. Even my Windows Phone has 4 cores in it. That's pretty astonishing. Soon you'll be able to buy 8-core phones. There's only one way you can leverage the multiple cores in your CPUs today, and that is to write multi-threaded code. So the second motivation for learning about web workers is to build multi-threaded JavaScript code that can and will leverage the multi-core devices we execute that code on. Again, if you don't do multi-threading, all you're doing with those other 3 cores in a 4-core machine is heating the room with them, because they are not executing your code. Now, let me ask you this. For those of you that have done multi-threaded programming before, you know it may be the hardest thing that you will ever do as a software developer. And people that don't agree with that, they've probably never written multi-threaded code. It's not, by the way, that it's hard to fire up threads. Anybody could create a thread in Windows. It's one function call. Somebody help me out here. What is hard about multi-threading? Getting it right, exactly right. And getting it right means synchronizing those threads, right? Figuring out where to synchronize the threads. I mean, you look at operating systems like Windows, and you look at frameworks like .NET. We have critical sections, mutexes, semaphores, locks, monitors, events, auto-reset events, manual reset events. There are a million different ways to synchronize threads. The problem, as those of you who have done multi-threaded coding before know, is figuring out where to synchronize them. You can't allow those 2 threads to collide over a piece of data. But wait a minute. If you're a C# developer, you probably went to college, went to university. You're probably very good at what you do. You have formal training in computer science. If you are a typical JavaScript developer, however, you may not have had that formal training. Now, how can someone who has a PhD in computer science, who finds threading and concurrency difficult, how's that going to fare with someone who hasn't been to school, who taught themselves to program with JavaScript? Isn't this just going to be a big mess? Well, let me tell you this. I think this is one of the most clever parts of HTML5. They have given us the benefits of multi-threading with almost none of the drawbacks, because with the schema they've come up with, it is easy to put work on background threads, but you never have to synchronize those threads. Can you believe that? Now, I'm going to show you an example here. It's one of the few examples in the real world of something using web workers to do something non-trivial. I'm going to specifically show you an app that leverages the 4 cores on this Lenovo Yoga I'm doing this on. And then I want to say a little bit more about what's really happening under the hood, about why we don't have to worry about thread synchronization when we use web workers. Take a look at this. Let's go look at a piece of code here. So back to Visual Studio, and I'm going to go into my workers folder. Again, you can download a zip file containing the solution, share it with your friends, look through all the stuff yourself. There are many more samples than the ones I'll have time to show you here. What I'm after right now is this one, workers. It's called multi-Mandelbrot1.html. While we're on the subject of Mandelbrot, here's Mr. Mandelbrot again. And even in IE, it renders faster than it did before. If you run it in Chrome, it's even faster than it was before. Now, I want you to notice something as this page paints. Did you notice, especially in IE, how it was painted in quadrants? Can you guess what I've done here? The UI in this page is not 1 canvas, but 4. And when this thing starts up, I fire up 4 web workers, 4 background threads from my UI thread, and I send a message off to each of those workers saying, do the computations for me for all the pixels in 1 quadrant of this display. As each thread, as each worker finishes those computations, it posts a message back to me containing all the pixel data that I need. Then, back on the UI thread, I paint those pixels onto a canvas. Now, you may wonder, so why don't I paint the pixels onto the canvas from the background thread? One of the big limitations of workers in HTML5 is they cannot touch the UI. In fact, let's talk about that a little bit more. I told you that they kind of gave us the best of both worlds here. We can run code in the background on other CPUs and other cores, but we don't have to worry about thread synchronization. Here's how they work that little piece of magic. Normally, when you write JavaScript code and that code executes, it executes in a very well-defined context. In that context, there's a window object, there's a document object, there are other JavaScript intrinsics. When you execute code in a worker, the code is executing in a background thread chosen by the browser, typically from a process-wide thread pool, although that's ultimately up to the browser and the underlying operating system. But that code runs in a very special context that's unlike anything you've ever seen in JavaScript before. In a worker context, there is no window object. You can't call window.alert. All you'll do is generate an exception in JavaScript because there is no window object. In a worker context, there is no document object. So you can't call document.getElementById to get a reference to a DOM element. In short, you cannot touch the UI of that page from a background thread. Now, do you see what's so clever about that? When you can't touch the UI from a background thread, and furthermore, when every worker runs in its own very special security context that makes it impossible for one worker to share data with another, you have no need for thread synchronization anymore. Because if threads aren't sharing data, they can just run independently. And by the way, that context that the workers run in, it's absolutely true. They cannot share data. You can declare a var in one worker. That var is in no way, no how accessible from the other workers. Again, when you can't share data, you do away with 99.9% of the need for thread synchronization. Let me show you really quickly here what this code looks like, and then I want to draw your attention to something that's a little bit unpleasant, and for which there is a fix coming in the future, most likely. So here's that page, and again, if you look at the DOM, instead of one canvas to draw that fractal onto, I've declared 4 canvases to define that quadrant that you saw. Now, take a look up here. Let's squeeze this over so we get a little bit more room. In fact, does the old Control-Shift-Enter still work? It does not. How about Alt-Shift-Enter? There we go. It's been so long since I used that in Visual Studio, I've almost forgotten about it. Here's what happens when this page starts up. So let's go right up here. This is the UI thread. This is actually executing inside a jQuery ready function, and I first grab a reference to each of those 4 canvases that you saw declared in the page. Then, image data in HTML5 refers to a bitmap. So I'm making this call to create an empty bitmap, one for each quadrant, one for each canvas of this fractal landscape. So I take the image data object that comes back, and I store it in a var. And then I do this, and this may be the most important part. Here's how you do work on a background thread using this API. You new up a worker object, and you pass into its constructor the URI of the JavaScript file containing the code that you want to execute on a background thread. By the way, I should tell you, do not assume, and this is a good thing, do not assume there's a one-to-one correspondence between workers and threads. Browsers are smart, operating systems are even smarter. What all the browsers in the world that support this do today is they basically submit a request to the operating system to have work done on a background thread. The OS manages a thread pool. It typically doesn't allow many more threads to be extant in that thread pool at the same time than there are cores in the machine. So you may have 100 workers. That doesn't mean you have 100 threads. It does mean that you have 100 separate logical works of unit that are being run somewhere other than the UI thread. So I new up the workers. I then register a handler in the UI thread for message events fired by the workers. There's a two-way communications mechanism based on a method named PostMessage that allows UI threads and workers to communicate with each other. Once on the UI thread, once I've created a worker, if I want to pass it a message containing data, I call PostMessage on the worker. That fires a message event on the background thread that the worker is running on, which I can receive and in which I can consume the data. Conversely, the worker can send data back to the UI thread or whatever thread created it by calling PostMessage itself. It too has the option of passing data. So what I'm doing right here is using JavaScript object literal syntax to create 4 objects, one for each worker, containing the data that that worker needs in order to know what quadrant it's rendering for. And then I pass it off to the background workers here. Guess what the UI thread does after that? Nothing. All it's doing is initializing, passing some data off to some workers. Each time a worker finishes its pixel computations, a message event fires. Here is the handling function. This property right here, the way I've set this up, contains the populated image data object, and I call on the UI thread, the HTML5 canvas is put image data method to draw those pixels. So the pixel computations are being done on the background threads. That means not only is it going to run faster on a multi-core machine, since the computations are being done in parallel, but in the first version of this Mandelbrot page that I showed you, in IE especially, where it took so long to do the computations, if I had tried to move the browser window or close the browser window or something, while I was doing those pixel computations, the browser wouldn't have responded. Here, not only is it making IE faster because it's allowing me to leverage these cores, but it's keeping the UI loop clean. So I could, if I decide to cancel out, I could close that browser window or whatever. So in this example, we see both motivations for doing multi-threading. We see better responsiveness, and we see better performance as a result of those multiple cores. So it's a win all the way around. Now, let me just show you this really quickly. If you want to see the code in the script file that's executing the background workers, it is in my scripts folder. It's called Mandelbrot1.js. Here's where the pixel computations are being done. Notice the very first thing each worker does when it starts. It registers an event handler for message events that allows it to respond when the main thread posts messages to it. Here in the event handler, I'm doing all the pixel computations, and then at the end, look what I'm doing. I'm post messaging right back to the UI thread with what is now a populated image data object. So pretty cool. In fact, it's almost too good to be true, isn't it? It's like we get to have our cake and eat it too. Let me tell you the ugly side to this, and something you need to be aware of if you're going to use web workers. For each of the 4 web workers I create, I'm passing in an empty bitmap object representing 1/4 of about 1 million pixels, or 250,000 or so pixels. From each worker, I'm getting back the same image data object populated with actual pixels now. In passing those image data objects from one thread to another, doesn't that violate the rule that I laid out a few moments ago, that you cannot share data between threads in HTML5 apps? If we're passing a big old image data object from one thread to another, we're sharing it, aren't we? What do you think's going on under the hood? In C#, for those of you who are C# developers, you can pass things 2 ways, by value and by reference, right? Yep. What happens when you pass by reference? You're passing a pointer. That's clean, that's performant, that's efficient, right? When you pass by value, what are you passing? You're passing a copy. Guess what? Currently, in today's browsers, when you pass data from one thread to another, you are passing by value. If it's a couple of simple integer variables, you don't care. The bigger, whatever it is you pass, bitmaps in this case, the more it's going to impact performance. Now, I'm passing about 1 megabyte of data in each one. It's physically having to be copied from one thread to another. You can imagine if these were much larger bitmaps, the performance would be terrible here. So be aware that today, when you use web workers, everything that you pass from one thread to another is being passed by value. Why? Because they want to make it impossible for 2 threads to share data. All of a sudden, this will get 100 times more complicated because we need to understand thread synchronization concepts, and we would have to have thread synchronization primitives. But there is some hope on the horizon. One interesting thing about HTML5 is that it is constantly evolving. One of the latest additions to the web worker specification is something called Transferable Objects. Chrome is the only browser that supports it now. Most likely in 6 months or a year, you will see other browsers supporting it too. What does a transferable object mean? It allows you to pass by reference, that is by address, an object from one worker to another in HTML5. So that's good, right? But wait a minute. If we're passing by reference, now we're going to need thread synchronization, right? No, because here's what they're doing. They're being clever again. The reason they call it a transferable object, ownership is transferred from the sending thread to the receiving thread. Once thread A has passed that object reference to thread B, the reference becomes undefined in thread A. So they really are letting us have our cake and eat it too. So they're letting us pass by reference, and they're making sure that there's still no way for those 2 threads to share data. Transferable objects only supported in Chrome right now. Hopefully will be supported soon in other browsers. Once we have transferable objects, we will not only be able to use web workers, we'll be able to use them very efficiently to pass large amounts of data as well. Okay, do you like what you see there? Is that a useful feature? Absolutely. It's about time we could do this in JavaScript. Let's see what else we can get our hands on here. I'll be very quick about this one. Web storage. If HTML5 is going to be a serious platform for applications, it must give us a way to store data on the client side, right? Now, historically, how have web applications stored data? They've stored it in cookies. There are a lot of reasons we don't like cookies. They pollute requests and responses. They go back and forth. They're not secure unless they're sent over HTTPS. They are limited in how much data they can store, typically about 4K, which is a good thing, because since they're shooting back up to the server that issued them in every request, if they were really, really big, like multiple megabytes, the app, every page load would be super slow. So again, if HTML5 is going to be an application platform, we need a way to store data on the client side, which is why HTML5 gives you something called web storage. Now, there's good news and bad news here. In fact, if I were grading the committees that wrote this, I might give them a B-. I'd probably give them a C+. The good news about web storage is you can store data on the client side. And you don't access the file system directly. You basically can't do that in HTML5 for security reasons. It basically gives you a sandboxed dictionary of key value pairs that you can write data into. That's what web storage is. The big downside, though, is the quota, the limits they place on how much data you can write. You can imagine that browser vendors are fearful of allowing anything written in JavaScript to just write unlimited amounts of data to a client device. If we allowed them to do that, I could write a malicious application that just filled all the storage on that phone or on that tablet or something with junk. So the HTML5 web storage specification recommends a 5 megabyte quota. But here's the problem. That is a shared quota. So if you do development for Windows Phone or iOS or Android, when you build a mobile application, every app that you build has a unique ID. In many of those systems, it's called an application ID or an app ID. And the nice thing about that on a Windows Phone, for example, when I write something into, say, local folder in a Windows Phone 8.1 app or into isolated storage on a Windows Phone 7 or 8 app, it is very private to that app. It's scoped by the app ID so that other apps cannot access it. The problem in HTML5 land is that there's no such thing as an app ID. Can you imagine what would happen if Microsoft said to the world, hey, from now on, when you publish an HTML5 app, you must come to us and get an ID for it first. And then you must publish it through the Microsoft store. Do you think that would go over well? No. It would go over like a ton of bricks. So there is no such thing as an app ID in HTML5 land. So here's something you should know if you don't know this already about HTML5. Everything in HTML5, especially when it comes to storage and security, is scoped by origin. What is origin? Origin is a combination of protocol, host, and port. So HTTP www.wintellect.com is one origin. Protocol is HTTP www.wintellect.com is the host. The port is the implied port 80. HTTP msdn.microsoft.com would be a different origin because it's a different host. Now, why is that important? Let's say that you're a big organization. Let's say you work for Microsoft's MSDN. That's a big organization back in Redmond, Washington, and other places as well. Chances are MSDN is going to be publishing hundreds, if not thousands, of HTML5 apps on their website. It's not that each one of those pages, each one of those apps, can only store 5 megabytes of data on a local device. It's that all of those apps that share that origin, that are published at msdn.microsoft.com, the sum total of what they can write to a device for a given user is 5 megabytes. So that 5 megabyte quota can go away rather quickly. When I teach this at Microsoft, what I tell Microsoft developers is this. Yeah, there's a 5 megabyte quota. You may not be able to write byte 1 because if there is one other person in your organization who used up that quota, you're not going to be able to write a single byte. So I teach them how to code defensively, how to use try and catch to make sure that if they try to exceed that quota, they can respond to it gracefully. So nonetheless, it's very, very useful. I'm not going to do a demo, just since we're limited on time, but if you look in my storage folder, in that solution that you can download, let's go in right here. You'll see some examples right here of web storage at work. Now, there is something else that you should know about real quickly when it comes to storage. Let's go back to PowerPoint to talk about this. IndexedDB. Web storage is not the only way to store data on the client side in HTML5. There's another way to do it called IndexedDB. Now, there's an interesting history with this. So for a few years, it was intended that HTML5 would have a client-side SQL database. In fact, to this day, if you go out to the W3C's website, you will find a specification there called HTML5 Web SQL Database. And the intent was that every HTML5 browser implement that client-side SQL database so we could store data locally. That initiative died. One of the reasons it died, remember, HTML5 is basically a set of APIs designed by committee. The committee could not agree on whose dialect of SQL to use. There are lots of different dialects out there. As a result, the entire initiative died. And for a while, it appeared that there would be no client-side database story in HTML5. Until some folks got together and came up with this thing called IndexedDB. It is a relatively recent addition to HTML5, but it gives you a lot more latitude than web storage. Number one, there is, in theory, no limit on how much data you can write to an IndexedDB. Now, the truth is every browser limits it, but most browsers allow a user to go into settings and internet options in IE11, for example, and specify how much storage an app can. In a database, you can create multiple tables, right? And you write rows or records into each of those tables. In an IndexedDB, you don't have tables, but you do have object stores, which are similar. And for a given object store, you can write objects into it. Remember, in JavaScript, anything can be serialized into JSON, so it's relatively easy for the browser to serialize that out. It works pretty well. There are great implementations of it today in Chrome and in IE 10 and 11, and I'm sure that because the spec is still evolving, those implementations will change, but I do all my testing of IndexedDB code in those two browsers. I do have an example in here that I'm just going to show you really, really quickly so that you can explore it some later on your own. And again, there aren't a lot of non-trivial examples of IndexedDB out there. If you look in my IndexedDB folder inside the samples, here's what you'll see. You'll see something called flightlog.html. Now, for those of you that don't know me, I should tell you I have a rather unusual hobby. I love things that fly. I really love things that fly. And I especially love things that fly that burn jet fuel. To me, the smell of jet fuel is better than the smell of coffee in the morning. I've got a shirt that says, I love the smell of Jet A. So in the U.S., we call them drones. What I build are not actually drones. I build very large radio control jets. They're about the size of small cars. For example, I've got a 1/6 scale F-16 that sits in my office. It's bigger than my computer desk. It's got a real jet engine in it, burns real jet fuel. It is amazing when it takes off. If we had more, in fact, one of my later sessions today, I may just play a video so you can see it. So when we fly these things, we log all the flights just like full-scale pilots do, and not because we want to be cool, but because if there are certain parameters we can track and see trouble before it's coming. After every flight, I can plug a little handheld computer into the controller for the jet engine. I get all kinds of interesting data out. Maximum exhaust gas temperature, maximum RPMs, maximum fuel pump voltage, things like that. These little things have tiny fuel lines, typically 4 and 6 millimeter lines. Did you know jet fuel loves to grow algae, by the way? How many of you knew that? If you don't learn anything else this week, you learned that jet fuel likes to grow algae. It really does. If it clogs the fuel filters in these little lines, all of a sudden we could lose that jet engine in the air, and these things don't like to glide very much. Guess what? If over time, with every flight, I track the maximum fuel pump voltage, and I see that voltage going up over time, what does that tell me? I'm developing a clog somewhere. That pump is having to work harder to get the fuel to the engine. So, originally I wrote a Windows Phone app where I track all that kind of stuff, but I thought, you know what? I should do it in HTML5 so that I can one day have this running on iOS and Android, because for some reason I don't understand. Most of my friends don't carry Windows phones. Hopefully they will be soon. But if I'm going to do it on iOS, I want it to run in HTML5. So basically, here is an app. I won't go through the code because I've got some other stuff I want to get to, but you can go through it. I have essentially an IndexedDB created. It has in it one object store. It has some records or objects inside it representing flights. At runtime, I query the data out of the IndexedDB, out of the object store, generate this HTML table. I demonstrate in this example how to do things like the equivalent of a select distinct even when you don't have a query language. I dynamically create buttons up here for the different jets represented in this database. And I show how to do filtering. If I, for example, click the F16 button, I re-query the IndexedDB. Remember, you have very limited querying capabilities, but you do have some. And I show just the flights for that particular jet. So again, I'll leave it to you to go through the code if you're interested. Let me tell you my biggest criticism of IndexedDB. It seems that with HTML5, even with the very best features, there are certain aspects of those features that make you just want to slap your head and say, what were they thinking? I bet a lot of you have done SQL before, right? And SQL is traditionally non-case sensitive, right? Exactly. You can at least set it, and most SQL databases default to non-case sensitive. Unfortunately, the queries, and I use the term loosely here because there's no query language, but the queries you do are entirely case sensitive, no option to turn it off. If you go out in the discussion forums and you look to see what developers are doing to do non-case sensitive retrievals from an IndexedDB, they're having to jump through all sorts of hoops, maintaining phantom columns and all kinds of stuff. It's crazy. There's actually a Microsoft employee back in Redmond, Washington, on the committee that designed IndexedDB, and I contacted him and I said, hey, what were you guys thinking? This is crazy. A case-sensitive database API? And he said, hey, look, he said, they added me to the committee late. The decision had already been made, so don't beat me up about it. So it may change because this is not a finished standard yet, IndexedDB, but I don't think it's going to because it's far enough down the road and it's being used enough now that it's unlikely to change. So it's more good than bad, but be aware that the queries that you do are sensitive, unfortunately. Now, I want to go back to PowerPoint and mention something else. Here's something else, and I want to skip on to a couple of slides right here. Something I think is incredibly important. If you are a web developer today, almost without a doubt, Ajax plays a role in the development that you do. Think about what the web would be if it weren't for Ajax. By the way, does anyone here know who invented Ajax? What company invented it? Yeah, it was an Outlook Web Access. Did you know Microsoft invented Ajax? Now, they don't get credit for that a lot. But remember, I've been working for them for more than 20 years, so I like to say good things about them when I can. Microsoft invented Ajax. Okay? So, technically, they invented something called XML HTTP request. It's an object you can create in a browser. It's that object that provides the API that lets you put asynchronous Ajax requests on the wire. For years and years and years, when we've been using this API, it has suffered from one almost fatal flaw, and I'll bet a lot of you have run into this. You can't go cross-domain with Ajax calls, right? Which means we as developers have to jump through all sorts of hoops. We have to bridge out to servers. We have to use tricks like JSONP or iframes to try to get cross-domain boundaries. Well, guess what? One of the features of HTML5 that I think is incredibly important is something called XML HTTP request level 2. Think of it as Ajax version 2. They've basically taken everything that Ajax would not do in the past, and they have fixed up Ajax to do it. One of the many things they've done, you can now go cross-domain. Technically, it's not cross-domain. It's cross-origin. Now, if you've ever done any programming with Flash or Silverlight, you know that both Flash and Silverlight don't allow you to go cross-domain or cross-origin by default either. But both Flash and Silverlight allow servers to opt in for cross-domain calls using policy files. Over in the Flash world, those policy files are called crossdomain.xml. In the Silverlight world, they're called client-access-policy.xml. In HTML5, to do cross-domain requests, you do have to opt in on the server side. You can't just walk up to any server anywhere and assume it will take a cross-domain request. But the designers of HTML5, or this feature in particular, didn't elect to use a policy file-based permissions mechanism. Instead, they made it protocol-based. If you haven't heard this term before, I want you to remember the CORS, Cross-Origin Resource Sharing. With Cross-Origin Resource Sharing, which is a header-based protocol that both the browser and the server implements, you can make cross-domain calls all day. I'm going to prove it to you and show you what this protocol looks like here. So there are very, very few examples out there in the world today, just examples of true cross-domain calls taking place. So I have stood up a server in Azure, which hosts a service written in WCF, which implements the server half of the course protocol. That means I should be able to bring up a page here from Visual Studio running from the origin localhost, and I should be able to make a cross-domain call out to Azure. Let's see if that is indeed the case. So let's go to my networking folder. It's called XHR2 cross-domain demo. We'll start it up there. And what this does is it allows me to type in the address, the zip code of any U.S. city. I live, for example, if any of you have been to the southeastern United States, how many of you have you heard of the Great Smoky Mountains National Park by any chance? Or anyone been there? Okay, if you haven't been there, you need to come. One of the prettiest parts of the U.S. I live right outside the Great Smoky Mountains National Park. So I'm going to type in my zip code, and if this works, we're making a call out over the internet, actually going out to Azure, cross-domain, and it tells me that I live in Concord, Tennessee, and it is currently 62 degrees Fahrenheit there. That is Fahrenheit, not centigrade, by the way. Some of you thought, boy, you think it's hot up in Hyderabad or Mumbai. Yeah, no, that's Fahrenheit there. So let me show you how this works. And by the way, let me bring up the awesome F12 developer tools in IE so you can see what it really means to use the CORS protocol. So let's do a network capture here. There we are. So I want to do a start capturing. I'm going to type in a different zip code, and I'm going to click that Get Current Weather button again. What you see there at the bottom is that Ajax request going across, and if we open it up and look at it, let's look at the details. Take a look at this origin header here. This is a header in the HTTP request. This was placed in there by the browser, and it identifies for a server that might honor a cross-origin or cross-domain request what origin this page came from. See, I can look now and I can see if this call came from www.microsoft.com, hey, I trust it. If it comes from apple.com, no way I'm trusting that, right? Nobody in their right mind would trust that. So this tells the server where the call came from. But take a look at this. Here's the response. The browser would have flat out rejected this call, the return from the server, unless the server in its response had included an access control allow origin header. This is the root of the CORS protocol, cross-origin resource sharing. The client identifies itself, its origin, with an origin header, and if the server will accept that cross-origin request, the server responds with an access control allow origin header, which in this case I've set equal to asterisk. That says, hey, I'll take a cross-origin or cross-domain request from any page hosted anywhere. You can be more specific if you want. You can say to that browser, yeah, I'll take a call cross-origin from Microsoft.com or msdn.microsoft.com, but not from Apple or Google. So you can be as specific as you want there. Honest-to-goodness cross-origin requests. Now, I wish we had another 3 hours. I'm sure you're glad that we don't. But remember, if you would like for yourself all of these samples and a lot that I did not show you, all designed to show off some of the best features of HTML5 as well as to show some of their limitations, go to my OneDrive right here. Remember that the URL is case sensitive. I will leave this up here for a couple of minutes so that you get a chance to write it down. And with that, thank you for coming to the session. I hope it's been good, and I hope to see you in some sessions later today. Thank you very much.